All right. Welcome to Unit 2, Lesson 4, Part 2 video. We are picking up with division of polynomials. And let's get started. If anything about this confuses you, go back and watch Unit 2, Lesson 4, Part 1, where we introduce it. Okay? So, I'm going to look. I've got no missing terms because I've got a 3 exponent. It's my degree. I have a 2. This is a 1, and technically there are 0 x's here. So my countdown is good, 3, 2, 1, 0. Here I have a 1 and a 0 x's. There are no x's there, so I'm good. So I can go ahead and set up my tabs. I know this is too wide, so I have 7x minus 1. Okay, it's too tall, I should say. I said wide. But now I got to figure out how wide this actually is. I have 1, 2, 3, 4 terms. Okay, so I'm going to draw my output arrows now out of the bottom corners. I have 1 for 7x cubed. The next at the corner is for my negative 8x squared. And let me stress, the sign should come with it. Now I have 2 more terms. So I should have 2 more output arrows. So I'm going to kind of just divide these up here. 1, 2. I have my negative 13x and my positive 2. Now for every output arrow that I draw past my corner, okay, that's my corner, I should draw a vertical line down to it. So this one and this one. So guess what? That is 3 wide. And whatever my answer ends up being up here, okay, above my tabs, okay, whatever my answer is up here, that's going to be my answer to my division problem. So we always start top left. This has to be 7x cubed. So what do I multiply 7x by? To get 7x cubed, I multiply it by x squared. Now, since I have that top, I can figure out what goes here. X squared times negative 1 is negative x squared. Now, here is where you need to be careful. Now I'm going to combine these 2 diagonal boxes for my output. All right. So what do I combine with? Now I'm adding. Okay, I'm combining. I'm not multiplying anymore. I have negative 1x squared. I need negative 8x squared. So I need another negative 7x squareds. Okay. Now I go back to multiplication. The place where people get tripped up the most is flipping back and forth between multiplication and addition. So let me do this with my highlighters. Love it. Anytime I am doing diagonal, okay, this is adding, right? Okay, so when I do this, these 2, combine those 2, I'm going to be adding to get my negative 13x, okay? Anything on the top here, I'm figuring out my multiplication, okay? So I have negative 7x squared. What do I multiply 7x by? To get negative 7x squared, well, a minus x. Okay, and now that I have the minus x up there, minus x times minus 1 is positive x, positive 1x. Okay, now diagonal. You see this left diagonal? What do I add to a positive 1x? So what would go here? So that would result in minus 13, well, a negative 14x. Now I need to flip back to multiplication. What do I multiply 7x by to get minus 14x? Minus 2. All right? And what is minus 2 times minus 1? It's a positive 2. Perfect. Worked out perfect. So my answer is this whole filth and flarn up here. Let's go. Yeah. This is my whole answer. It looks a little messy there. Don't just leave it like that. Do the common courtesy for the person grading it of writing your answer, x squared minus x minus 2. That is a great answer. I love it. If you want to try this one on your own, go ahead. I am about to rip through it. Now, I notice I'm missing some terms. I do not have an x to the 5th here. An x to the 5th should be between 6 and 4. My next term is 1, so I'm also missing, not only am I missing a power of 5, I'm missing a power of 3. I'm missing a power of 2. Okay? So I should really rewrite the top as x to the 6th plus 0x to the 5s plus my 4x to the 4 Okay, plus 0x cubes plus 0x squareds minus 4x minus 1. Wow, that's a lot. And I need to do that because my exponents should be going down one at a time. Okay, 6, 5, 4, 3, 2. That's an x to the 1, and there are 0 x's here. Okay, I need to fill in any missing terms with a 0. This was missing, this was missing, and that was missing. Okay, all over. Oh boy, the bottom. I see an x cubed, and then I have 0 x's in the back, so I'm missing my 2 and my 1 exponent. So I have x cubed plus 0x squareds plus 0x to the firsts minus 1x to the 0. Of course, we don't have to write our x to the 0. Okay? Those are my terms where I filled in the missing items with a 0. Okay? My polynomial on the top, I filled in my missing power of 5, power of 3, and power of 2 with zeros. My denominator, my polynomial down there, x squared, x to the first were missing, so I filled them in with zeros. And you need that. Okay? Now here it goes. My bottom term, let me see, do this in black. I have 1, 2, 3, 4. That's how tall it's going to be. X cubed, 0x squared, 0x to the first, and minus 1. I just don't know how wide this thing is going to be. Okay, so that's my row for x to the third. That's my row for x squared. That's my row for my 0 x's. And I have a bottom row for my negative 1. Okay, so my output arrows. I have x to the 6th. Should come out of here. That's x to the 6th. My next term, 0 x to the 5th. Okay, my next term, 4x to the 4ths. All right, my next term, 0x cubes. How many terms do I have left? I have 1, 2, 3. So I should have 3 more output arrows. So I'm going to space them evenly along the bottom. And all of these arrows past my corner should get a vertical line down to it. So 1, 2, 3. And that goes for 0x squareds, negative 4x, and lastly, minus 1. They should all get vertical lines. Bang, bang, bang. That looks like a lot, but keep in mind, anything that's going to be multiplied times a 0 will be 0. I'll show you as we get going. All right, so this has to be x to the 6th that's output. All right, so what do I multiply x cubed by to get x to the 6th? Well, x cubed times x cubed. So now I can just go down that column and multiply everything times x cubed. X cubed times 0, well, that's just 0. X cubed times 0, well, that's just 0. And x cubed times negative 1 is negative x cubed. All right, this column right here, all these multiplying, they're all going to be zeros. I multiply 0 times anything, they're zeros. That's easy. Now, oh, this is where it gets good, friends. What goes here? I need to combine something with 0 to make it 0. Well, how about 0 and 0 give you 0? Okay, it's not bad. Okay. Now, what do I multiply times x cubed to get 0? Well, I multiply 0. Okay, which means, oh my God, I can multiply this vertical column. 0 times anything is 0. All right, good. Now, you got to make sure you know you're going back and forth. These 3 should all combine to give me 4x to the 4th. So I have 0 plus 0. I need to have this be 4x to the 4th, and it would output 4x to the 4th. All right. So $1 million question is, back to multiplication. What do I multiply by x cubed to get 4x to the 4th? 4x. All right. Well, I have my two zeros. I'm going to do this whole column now. I have 4x to the fourth in the top tab, 0, 0. What is 4x times negative 1? That's negative 4x. All right, cool. Now, okay, let's go next. I can start to add things here, but let's not get ahead. Let's do our next one. Let's fill in this top tab. Now, keep in mind, again, you got to make sure you know what you're doing. All these diagonally should add to be 0. Okay? I currently have negative x cubed, 0, 0. So what do I combine with a negative x cubed to get 0? A positive x cubed. All right? Now I go back to multiplication. What do I multiply times x cubed to get x cubed? 1. All right? So let's go down this column. All right? 1 times negative 1 is negative 1, and that's perfect. That's exactly what I get. Let's make sure our columns add up, okay? I'm going to go green. Let's go purple. These three, 0, 0, and 0, give me 0. That's good. All right? 0 and negative 4x give me negative 4x. That's good. And my negative 1 gives me negative 1. Man, that works out. You see all those zeros? So when you have to fill in the missing zeros, that really doesn't make it more complicated. The only complication that adds is actually putting them in. Because when I start to multiply, any product will be 0. 0 times anything is 0. It's nice. It's beautiful. So what's my answer? What's my quotient, which is the answer to a division problem? It's this right here. Okay, that's a positive 4x. So let's write it nice and neat. I have x cubed. In my answer, I do not have to put 0x squared. You can if you want. But then I have plus 4x plus 1. That is correct. If you wanted to put x cubed plus 0x squared plus 4x plus 1, that's fine. Okay, if this was a short answer, that is 100% acceptable. But if it were multiple choice in a final, it would look like this. It would not look like this, okay? But short, those are the same. If it was a short answer, that'd be fine. Ooh, that's a big one, but it's done. Oh, everything has been fine and dandy because we have not had a remainder. We have not had to deal with remainders. And if you are getting good, if you're getting good at this, coffee. Speaking of good, coffee is so good. Peppermint mocha creamer. Anyways, back to math. What happens when there's a remainder? Right? If you're starting to feel comfortable with these tabs and multiplying and adding, because everybody loves multiplication and addition better than division, all right? It's really the same thing. With there's one minor exception, and that is in our bottom right-hand tab. That's why it's so critical that we start with our top left tab, all right? And let me explain that by doing this problem. First off, you should realize this is the same thing as saying 4x squared plus 23x minus 16 divided by x plus 5. Okay? If you went ahead and did this on your own, you would realize that the bottom right-hand corner does not match. So wait for me to get there, all right? So I'm going to set this up. I realize right off the bat there are no missing terms. I know this is going to be too tall. X and a positive 5. And I have my output arrows, 4x squared right here. Right here I have 23x. And I only have one more, minus 16. Boom, right there. And that last one is where I should get a vertical line. So it's too wide. Easy. And we're going to go ahead and do this kind of quickly. We always start top left. Always, always. Okay? I wanted you to get in that habit for this reason. 4x squared. So I multiply a 4x times x to get 4x squared. So now I can say 4x times 5 is 20x. Now this has to add with 20 to get 23. So 3x and 20x give me 23x. All right, back to multiplication. What do I multiply times x to get 3x? Well, a positive 3, silly. And 3 times 5 is 15. They do not match. Okay, this means I have a remainder. Well, let me explain that. Okay, let me restate that. If your bottom right-hand corner does not match, it's either one of two things. Either one, you have a remainder, or two, you messed up somewhere. There shouldn't be, maybe it should match and you messed up with your math somewhere. This particular one has a remainder, okay? I'm confident in our math skills. There's a remainder. So how do I figure out what it is? Here's how you do the remainder, okay? Whatever you end up with here, okay, it's the adjustment. What do I do to 15 to make it negative 16? Okay, I need to subtract 31 from 15 so that it equals negative 16. This is my adjustment to make my bottom right-hand corner match the output. This adjustment right here, that's your remainder. Let me state that again using highlighters because I love them, okay? If this does not match your output, okay, you want them to match. You want my 15 and negative 16 to match. So what would I have to do to 15 to make it negative 16? I would have to subtract 31. And whatever your adjustment is to make them match, that's your remainder. All right? So let's write a little note to ourselves here. My remainder, that equals your adjustment or your addition or subtraction, whatever you want to say. You need to adjust, however you need to change, okay, your adjustment to your bottom right so that it equals your, I should say its output, so that it equals its output arrow thing. Okay, does that make sense? So if some of you are like, man, Visca, I couldn't just off the top of my head think that I need to subtract 31 from 15 to get negative 16. So this is what you do. Set up a little equation. I have 15. I want it to equal negative 16, right? So I'm going to, whatever my remainder is, I'm going to call that R. I've got to do something to 15 to make it negative 16. You can always set that up. Okay, whatever's in your bottom right-hand box, you add R, which is your remainder, set it equal to the output. So how would I solve for R? Wouldn't I just subtract 15? So my remainder is negative 31. And that's your adjustment. But I like to put it there visually. That way I understand how I got negative 31. That's what I had to combine with 15 to make negative 16. Okay? If you need to re-listen to that, rewind it, hear me explain it again, that's fine. Now, how do I write my solution when I have a remainder? Okay, I'm going to write it up here in the top right. My answer is obviously 4x plus 3. And what I do is this. That's negative, correct? Minus my remainder over what was dividing into. I was initially dividing x plus 5 into it, right? That's how you would appropriately write your solution. This part here, that's your quotient. That's your answer, your quotient, all right? This part here, that's your remainder. And this part here, you call that, that's your divisor. Okay? That's what divides into your whole problem. This is dividing into this. This is dividing into that. Okay? So, brief explanation. All right? Not horrible. Like I said, if you're getting familiar with tabs, that's fine. And I'm just going to undo this until we get to our answer before I get rid of that circle. Okay? Works the same exact way. The only difference is these don't match. Okay? So what adjustment do I need to make? I need to subtract 31. And that minus 31 is my remainder. All right, let's try one of these. Okay, a simpler one. Okay, a simpler one. This, it's a little weird, this notation. This means quotient. That means R means remainder, and this X minus A, whatever, that's what you're initially dividing in. So, you know, it's just exactly what I explained to you. All right? It's exactly what I explained. Now, there are no missing terms. Too tall, X minus 3. Bang. My output arrows, I have X squared. I have 6X. And minus 5, I have one more. Boom, minus 5. That means vertical line. It's too wide. This has to be X squared. Has to. Okay? X times X is X squared. X times negative 3 is negative 3X. What do I combine with negative 3X to make 6? 9X minus 3X is 6X. So what do I multiply by X to get 9X? Well, positive 9. 9 times 3 is negative 27. Oh, they do not match. I know my math is correct, so here we go. How do I turn negative 27? What adjustment do I make so that it equals negative 5? I add 22 to it. And that plus 22, that's my remainder. Okay? You don't believe me? If I have negative 27, I'm going to combine something to it to make it negative 5. All right? Well, I would have to add 27 to both sides. R would equal a positive 22. Okay, so how do I write my solution? It's X plus 9. That's a positive 22. So plus 22 over whatever is on the right-hand side here, X minus 3. And that, my friends, is absolutely perfect. All right, why don't you try this one? Go right ahead, pause it, because I'm about to do it right now. I notice I'm missing my X to the 1, so I'm going to really write that. I'll write it above here. I've got here. I've got X cubed plus 2X squared plus 0X to the 1s plus 41. Okay, so I'm just going to, that's going to replace this. I know this is too tall, so I have X and a positive 5. I'm going to give myself a little bit of room here. Oh, wait, I'll just do it this way. All right, so X cubed. Oh, I know this is 2. Okay, so I have X cubed. 2X squared. I have 2 more terms. 1, 2. Both of those get vertical lines to them. And I put my 0X's here and my plus 41 here. Wow. This has to be X cubed. So I multiply X squared times X. Okay, so now I get X squared times 5. I get 5X squared. Now I need to add whatever's here to 5X to get 2X. Well, 5 minus 3. So it's a negative 3X squared. That combines perfectly. So what do I multiply by X to get negative 3X squared? A minus 3X. And minus 3X times 5 is negative 15X. All right. Okay, cool. So I have 0 as an output. If I have negative 15X and I want 0, I need a positive 15X. And what do I multiply by X to make it positive 15X? A plus 15. Dear God. All right. So 15 times 5, I know, is 75. They don't match. I know my math is correct because these all diagonally combine and add up. Everything's nice. So how do I make 75 into 41? What adjustment do I need to make? I need to subtract 34. Okay? That's my remainder. So let's check that. If I have 75 and I add something to it, which is my remainder, to get 41, I subtract 75, I subtract 75, and my remainder is definitely negative 34. Okay? So, yeah, 5, 7, that works. So how do I write my answer? It's this. X squared minus 3x plus 15. Okay, yeah, that's, you know what? Being picky. I'm going to write it nice. X squared minus 3x plus 15. That is a negative 34. So it's minus 34 over what I originally divided in, which was x plus 5. Man, you guys are great. Now, you might have the question, but Visca, can I write it like this? Can I say x squared minus 3x plus 15 plus a negative 34, because that's my remainder, so I want to put that up there, over x plus 5. Yes, you can absolutely write it like this. They're the same thing. Just be aware that if this is multiple choice, maybe it's written like this, but it might be written like this as well. As long as you know they're the same thing, you're fine. Okay? Good, good. We're getting comfortable with this. I like it. All right, let me introduce you to something called the remainder theorem. All right, we're going to do this remainder theorem, a couple examples, and then we're going to stop, and we're going to have a part 3 to this one because it's very important. And I really want to teach you synthetic division, which is what part 3 will be. And that, I think, will be the easiest of all this dividing and multiplying thing. Okay, so the remainder theorem. What is the remainder theorem? Okay, if I T-bone, which means solve, right? If I T-bone, which means solve, set equal to 0 and solve, my divisor, okay, then I take that number, I take whatever the result is from putting your answer from your divisor, okay, I take that number and plug into dividend, the result is your remainder. You do not have to divide to find a remainder. You can essentially substitute in. Okay, you might be like, what's the divisor, dividend, Visca, it's been a while. What do you talk about, T-bone solve? Let me show you right here, okay? Find the remainders of the division problems we have. Number 1, this is what's dividing into this, okay? So I know this is on the right side, and this was wrapped around. We called it the product. But for the sake of our division problem, this is your divisor. That's what's going in. This is your dividend. This is what we're dividing the divisor into. So if I take x minus 4 and I solve it like it's a booty cheek, right? I T-bone it. My x would equal a positive 4 because x minus 4 equals 0. I add 4 to both sides, and x would equal 4. All right? I take that number and I plug it into the dividend. That's the dividend. So what do? If I have x squared minus 6x plus 11, and I substitute a 4 in for my x's, that's 4 squared minus 6 times 4 plus 11. 16 minus 24 plus 11. That is a horrible 4, people. That is negative 8 plus 11. The answer is 3. Therefore, in this division problem, I would have a remainder of 3. All they're asking you for is the remainder. They're not asking you for the quotient. This remainder theorem does not give you the quotient. It only gives you the remainder. Okay? So, let's do this on a problem we just did, just to show you that it works. Let's go back one. Okay? This remainder was negative 34, right? So I'm going to go ahead and erase all this. Bang. Holy cow, is that one? Oh, almost. So I know my remainder should be negative 34, right? So let's do the remainder theorem here. So I solve for x plus 5 equals 0. So my x should equal negative 5 because negative 5 and positive 5 are 0. And I'm going to plug that into here. So I take negative 5 and I cube it plus 2 times negative 5 squared plus 41. I'll put this in a calculator so you believe me, but this is negative 125. Okay, this is 25 times 2, 50 plus 41. So I got negative 125 plus 91. If I subtract those, and I get negative 34. That works out. That's exactly right. I was going to put it in the calculator, so, you know, and I still will. I'll check my math. You don't believe me, you're like, that's weird, Visca. Let's do this. Negative 5 cubed, okay, plus 2 times negative 5 squared, plus 41. Bang, negative 34. It works every time, and I love it. Okay, again, it doesn't give you the quotient. It doesn't give you what the answer to the division problem is. It only gives you the remainder. Okay, why is that important? Well, why don't you try 2 and 3? Oh, just 2. I just have 2 here. Look at that. 1, 2. Yeah, I do. Bang. Okay, we're going to check expression of factor. All right, so we're going to answer that question in a minute. Why don't you guys pause and do this? Because I'm about to do it right now. If I solve this, x should equal 2. Okay, so I'm going to plug a 2 into all these things. 3 times 2 cubed plus 17 times 2 plus 25. Notice I don't have to fill in missing zeros because I'm not actually dividing. I'm not using the tabular method or the reverse tabular method. Okay, this is 3 times 8, plus, which is 24, plus 34, plus 25. Ooh, groovy. So 24 and 25 is 49, plus 34. That's 3, carry the 1, 83. That's your remainder. Your remainder is 83. Yahtzee, good. I'm in love with it. So this is why we like to know the remainder theorem. Now, before I even answer this question, the remainder theorem, you might do this and say, Visca, you know what? I'm really comfortable doing reverse tabular. If you want to use reverse tabular to find the remainder and do all that work, your remainder will end up being 83. You can do that. That's fine. This is just a shortcut. All right? If you needed to find the quotient, you still need to do reverse tabular and all that jazz to find the quotient with the remainder. If you only need the remainder, you can do just this. Again, you can divide the whole thing out and find out what the remainder is, because some people have that mentality where I don't want to jam too much into my brain, and I'd rather just stick with what I know to get an answer, and that's fine. This is much less work to find only the remainder. So why is that critical? Because what happens if the remainder is 0? What do I know about division and multiplication that if I divide something, I get a remainder of 0? If a remainder is 0, then your divisor, or the number or expression, divisor, that you're dividing in is a factor. Remember, you know, we factor things. It's important to know how to factor, right? I say you need to know that all the time. So if I do the remainder theorem and my remainder is 0, then I know what I'm dividing in is a factor. For example, if I have 24 divided by 5, okay, 5 goes into 24 4 times with a remainder of 4. This remainder is not 0 because 5 isn't a factor of 24. Okay, but if I take 24 and divide it by 6, well, that goes in 4 evenly. The remainder is 0. Since the remainder is 0, 6 is a factor of 24. 6 times 4 is 24. Okay, so this remainder, if they give you two expressions and they say, is this expression a factor of this one? You can divide them out and see if they divide in evenly without a remainder. That's fine. Or you can just use the remainder theorem, because if the remainder is 0, it is a factor. Okay, it is a factor. Bang. I think we have, okay, these two problems and we're going to be done. Whew, this is a long one. Okay, using the remainder theorem, we can check if an expression is a factor. So, is x plus 3 a factor of x to the fourth minus 10x squared plus 9? Why or why not? They always like to say explain, use words. This is Common Core, drives me crazy. Anyways, let's set this equal to 0. I would get x equal -3. I'm going to plug a -3 into each one of these. Let's go. -3 to the power of 4 minus 10 times -3 squared plus 9. This is going to give me 81. Okay, -10, that'll be a positive 9, minus 90 plus 9. Did I do that right? 90, 27, 81, it is. Okay, so 81 and 9, if I combine them, give me 90. Minus 90, that equals 0. Okay, that is a factor, but they're saying why or why not. Okay, by remainder theorem, since remainder is 0, it is a factor. That's all you need to say. By the remainder theorem, if the remainder is 0, it's a factor. Please don't write this. Please do not write since there is no remainder. There is a remainder. It's 0. 0 is actually a value. Do not say there's no remainder. It's a factor. That is wrong. There is a remainder, and because the remainder is 0, it is a factor. All right, you want to try this next one? Go right ahead. Justify. I am taught, or I teach, and I have been told that justification means showing your work. Explain, or why not, means to use words. Okay? So let's do this. X would equal a positive 2. So I'm going to plug that into here. 2 times 2 to the fourth minus 2 cubed minus 18 times 2 squared plus 9 times 2. I just plugged a 2 in for all these x's. 2, 4, 8, 16. 2 to 16, that's 32 minus 8. Okay, ooh, 4 times, you son of a gun. 4 times 18 is 72, so minus 72 plus 18. That looks about right. 32 and 18 will give me a positive 50. Minus, okay, -8 and -72 is minus 80. That's -30. That's your remainder. Okay, your remainder is -30. So x minus 2 is not. Yeah, I'll be okay. I was about to write not a factor, and I wrote not. Is not a factor, since remainder does not equal 0. The remainder is -30. You could say by remainder theorem. I always like to add a little bit more detail because I like to assume the person correcting it might not know, even though they should. Okay? This is a great place to stop because we are going to get into synthetic division, and you're going to ask, why haven't we done synthetic division the whole time? Because you can't really do it the whole time. But it is easy and cool and nice. All right, we'll see you later for Unit 2, Lesson 4, Part 3, coming up to a theater near you. In fact, I think that video is going to be shown at the end of Avengers Endgame. They were having difficulty coming up with that, like, end credit little teaser, and I think they're going to show my next video. It's going to be awesome. I can't wait. I'm lying. I'll see you.